In this lesson, we're going to be talking about configuring OSPF not so stubby areas and really what the effect of that is. If we look at that in the context of our overall lesson plan, with regard to OSPF routing, we're getting kind of towards the end of OSPF routing. This is where we are right now, configuring OSPF not so stubby areas. I don't think this lesson will take a couple hours. It might take a little bit more than an hour, but depends on whether or not you guys have any questions or anything. And then we will look at NSSA redistribution. How do we manipulate values that are coming into the NSSA area? How do we change the seed metric? How do we affect whether or not it's going to be an ON1 or an ON2 route and so on? And then we'll talk about default routing for OSPF NSSA, because this is the only area type, special area type that doesn't actually inject the default route from the ABR. We'll talk about why. In that lesson, we'll talk about why that is, why Cisco chose to inject the default route from the ASBR in a stub area, totally stubby, and a totally not so stubby, but not the not so stubby. So, and then we'll look at OSPF NSA translator elections and forwarding addresses. The translator will talk a little bit about, in this lesson, the idea that we go from a type 7 to a type 5, and how the ABR can advertise a route but doesn't become the path for the route. That's an interesting concept that we'll see today. Then we'll finally get into path selection, where we'll talk a little bit more about what Mike was asking about one of the last lessons, is how do we make a decision on intra-area, inter-area, OE1, OE2, ON1, ON2 routes. And then we'll wrap up by talking about some of the enhancements like authentication, summarization, and then we'll wrap up our OSPF discussion. Okay? So, that being said, let's go ahead and get into our lesson, which is configuring OSPF not so stubby areas. So we're going to talk about what is an OSPF not so stubby area, what are some of the caveats, what are some of the requirements that we have to configure an OSPF NSSA, how do we do redistribution into an NSSA, and most importantly in this lesson, how do the path selection rules change when I start to use an OSPF NSSA as opposed to, say, a stub or totally stubby area or even just a normal area in my OSPF design. So if we take a look at our topology and what we're going to be doing in our topology here, we've got a 3-area design, multi-area OSPF design. This is the same design we've been using for a couple of our lessons. And in this particular case, we're going to make area 2 our NSSA. We'll actually even add a couple of routers. I need to add probably another router. We'll break up that Ethernet segment there and add another router so that we can kind of manipulate how we go into the NSSA and take a look at some of those concepts. So we'll be adding another router to this topology. Move that over there. So we'll put another router here, connect it to the ASBR, and really kind of identify how the path selection process works. So our focus is going to be on area 2 as the NSSA. But before we even get into that, let's make sure that we just have basic reachability without the NSSA. We won't inject some external routes just yet. We will eventually. But actually, you know what? I'll probably just go ahead and make router 2 an ASBR as well, and inject some external routes so we can see how that would affect the process of sending those external routes into area 2. You want to make sure, and this is extremely important for the process on the CCIE lab, make sure that you test all of your basic reachability first before you go in and you add anything else to the topology. Test your layer 2 reachability, test your layer 3 basic reachability, verify, implement and verify all of your advanced behaviors, implement and verify all your basic behaviors before you decide to go in and implement and verify all of your enhanced or advanced behaviors. if that's gonna be an option on the test. Obviously, time is of the essence on the exam, so you may not have an option to do that, but we're going to try to do that anyway as much as possible, and that's what we're going to start with today. So let's take a look at the graph of OSPF and see what we see. First thing I'm going to do is I'm going to go into router 2, and just so that we can generate some additional routes, I'm going to come into router 2, and let me just do a show IP interface brief. And let's see, we got a loop back there, so I'm gonna do a show IP OSPF interface, and pipe include interface, and let's see, yeah, so we're running OSPF on 192.168.2.1. We're running OSPF on 172.16.12. So we're running OSPF on our loopback and our Ethernet interface. So let me go ahead and create another loopback, interface loopback 100, IP address, and we'll just call it 22, 22, 22, 22, 255, 255, 255, 255. Oops, too many dots there. Now the reason I'm doing this is I want to go into router OSPF, do show IP protocols. I want to go into router OSPF 1, and I'm just going to do a redistribute connected. So let's do subnets, because what I want to do is I want to send in that 22 subnet so that it shows up in OSPF as an external route. So we just made router 2 an ASBR in this particular case. So if I check my graph on router 4, show IP OSPF database, we're going to see that the external network is coming in. Router 4 is actually an ASBR as well. It's sending in the internet prefix. So 22, 22, 22, 22 is coming in. Now, this is, and I'm going to get into this more in this particular lesson here, especially with the NSSA configuration. But as I'm investigating the graph, one of the things that I told you guys when we first started talking about OSPF is about routing to nodes, not to networks. Okay, so it's really important. Hold on, we got a bit of an echo here. All right, I think Tim muted himself. So it's really important to understand how that SPT graph is going to be analyzed by OSPF, because just because something is in the database does not mean it's actually reachable. And that's a very, very important concept. So if I do a show IP, OSPF database, and I do my external LSAs, I can see that, well, actually, let me just point this out. The very first thing you should always check is that right there, right? I don't think I mentioned this. I may have mentioned it briefly in some of our previous lessons, but the router bit set to on means that this is a reachable node. It means that we've converged and we understand how we've solved the SPF or the SPT tree, the SPF tree for this particular destination. I'll show you later. I'll create a null zero route. I'll try to create a null zero route to black hole some traffic and show you how that disappears. So I am on router 4. If I look at my topology here, and I'm trying to reach that 22, 22, 22 loopback that sits behind here. In fact, let me go ahead and put that in. Duplicate this, and we'll go into loopback 100, and we'll just put in 22, 22, 22, 22/32, and that's coming in as a redis connected. So that means that this router here, duplicate that, let's duplicate this. This router here is now acting as an ASBR in a normal area. All right, we're not going to configure area 1 as a special area type. So from our previous discussion, we know that if I am sending in routes from a redistribution process, those are going to come in as type 5 LSAs, and they're going to be sent across to router 1. Now, if I go back to my database, and I'm looking again from router 4's perspective, If I do a show IP route 22.22.22.22, there's two things that you need to understand about this output. And this is really what this entire lesson is about. I know we said NSSA, and we're certainly going to look at these configurations from the perspective of an NSSA, but it's extremely important that you understand how to interpret the recursion process that OSPF uses to reach destinations. Because we can see here that there's a metric of 20. It's coming in as an external type 2, so OE2, but it also has something here called a forward metric. And that's really, really important, because when router 4 is trying to reach this external route, it is not using this seed metric that was established when I injected the route from router 2. That is the default seed metric for external routes that get redistributed into OSPF. So, and we can change that. And one of the other lessons in the future here, we're going to talk about how we can manipulate the redistribution process. But by default, these routes will come in as OE2 routes, external type 2, with a seed metric of 20. Okay? And that metric will stay the same regardless of wherever I am in the topology. But if I look at the path and I consider where the route is coming from, and then I consider where router 4 is, this is an Ethernet link between router 4 and router 1, and this is an Ethernet link between router 1 and router 2. So obviously the cost of the route, the cost to reach the destination is not 20. Well, actually it's more than 20, right? Because the seed metric was 20, plus we have an overall path of 20. Now, that's what this is referencing here. This is the initial seed metric that was sent in with the route. This is the type of route. This is the metric to reach the device that's advertising the prefix. So if I do a show IP OSPF database external, I can see here that router 2 is the advertising router, which is the ASBR. And in this particular case, the forwarding address is quad 0, which indicates that that is the router that's originating that route. This behavior will change when we get to NSSA and we have multiple ABRs in a not so stubby area. We'll talk more about the quad 0 concept. Okay? Now, it states here that the metric is a 20 for this route. This is the advertising router. This is the external network number. But if I do a show IP OSPF database, you will see here that there is something else that allows me to identify information about 2.2.2.2. If I do a show IP OSPF database router 2.2.2.2, I have no entry for that ASBR. So I have no type 1 LSAs that indicate how I'm going to reach that particular external or that particular ASBR. Does that make sense? So there has to be a way for me to solve the tree, some way for me to identify how to route to that node. I understand that the external network exists, but I don't have a type 1 LSA route or an intra-area LSA route to reach the node. And again, OSPF is all about routing to the node, not to the network. All right. So in the case of a standard or a normal area, we have these show IP OSPF database. We have these summary LSAs. The advertising router is the ABR. And what it identifies in this case, actually, let me do, that's the wrong one. Those are my type 3s. Let me do a show IP OSPF database one more time. Because what I should be seeing is, I meant to say summary ASB. I said summary and I was looking at these 4 LSAs here. So show IP OSPF database. And if I come in here and I do question mark, we're looking for the ASBR summary. All right. Now, this is the interesting part about this, because this identifies how I reach the ASBR. These are my type 4 LSAs. Remember we talked about type 1, type 2, type 3, type 4, type 5, and type 7. We didn't quite get into the type 8 and the type 9 for IPv6. But so if I do a show IP OSPF database 1.1.1.1, sorry, router, I can see that I do have a way of reaching 1.1.1.1. This is coming in as a type 1 LSA, and it describes the network and actually all the networks that router 1 is advertising. So there's always kind of this recursive process for identifying how we reach destinations within OSPF. In the case of router 4, we're using a type 4 LSA to identify how to reach the ASBR. We're using the type 1 LSA to identify how to reach the ABR, and we're using the ASBR to identify how to reach the external network. And there's always this recursion. So certainly you could just do a ping 22, 22, 22, 22, and we certainly have reachability, but it doesn't necessarily mean that doesn't define specifically how we're learning about how to get to that destination. And one of the things that you have to be extremely well versed in, especially as you get into more complex topologies, is how do I solve the tree? And that's where understanding the LSA types comes in. We're not just simply analyzing routing tables, we're analyzing the tree. And it's not always very intuitive to be able to identify that. So I certainly can come in here and I can do a show IP route. And we'll see that prefix listed in here. But this metric here doesn't accurately describe the overall path metric to reach that destination. That's the initial seed metric that gets sent in. Now, if we send it in as an OE1 route, we'll talk about that in the next lesson, but if we send it in as an OE1 route, we could infer what the overall path metric is because of the way that the E1 routes are calculated. So it does look like we have full convergence here. I've got 2 OIA routes from area 1, 2 OIA routes from area 2, and all of my standard O routes and my connected routes. There are, if there is no type 4, all right, so let's take a look. We're sending in this route from router 2. If I go to router 3 and I do a show IP OSPF database, show IP OSPF database, you will notice here that we don't, actually not router 3, router 1, sorry about that. I want to go on to the ABR, show IP OSPF database. You'll notice here that we don't have in the area, remember router 1 is connected to area 1, which is the area that router 2 is attached to. You'll notice in that area, within area 2, that we do not have any, well, actually, we do because of router 4. So to say we don't really have any summary ASB links. Let me show you a different way, because I forgot that we were sending routes in from router 4 as well. Certainly we can see the 22, 22, 22 route. But if I do a show IP OSPF database router, 22, 22, 22, 22, we see again that we don't have any type 1 LSAs that describe that external network. That makes sense because it's not part of OSPF natively. But if I do a show IP OSPF database 2.2.2.2, sorry, router 2.2.2.2, we can see that we do have layer 1 reachability to that particular node. So in the case of router 3, because router 3 in the case of router 1, because router 1 is participating in the same area as router 2, we don't need a type 4 LSA to describe reachability to 2.2.2.2. So let me see, let's do a show IP OSPF database external. Same concept here. We still see that the link state ID is the external network that we're advertising. The routing bit is on, so that means it's reachable. The advertising router is 2.2.2.2. But rather than using a type 4 LSA to be able to reach the quad 2 address, we're going to use our internal type 1 LSA. Again, the forwarding address is still 2.2.2.2 because of the way that the area is set up as a normal area. So the most important thing in any kind of route, as I mentioned before, is that the routing bit is set. Because if the routing bit is not set, there is absolutely a problem in completing the overall OSPF graph. And that's a really important concept to understand. So in this particular case, I'm kind of trying to identify whether or not the ASBR is in my area or if it's not in my area. And the reason why that's important is because the advertising router will allow us to identify how recursion is going to work to get to that ASBR. You know, are we going to use a type 1 for recursion, or are we going to use a type 4 route for recursion? If the ASBR is inside of my area, as it is in this particular case, we're going to use a type 1 LSA for recursion. If the ASBR is outside of the area, we're going to use a type 4 LSA to then get to a type 3 LSA, which then allows us to get to our type 1 LSA. Okay? It's not really self-explanatory in the database. That's the problem. If you look at the database, you know, one does not necessarily point to the other. So it's really important to understand what the effect is of the overall topology. And I think that's the most difficult thing to understand with OSPF is the overall effect of the topology. Okay, so let's see if we can do some other discoveries here. So we're definitely seeing summary ASBs in area 2. Going back to our topology here, why am I seeing a summary ASB in area 2? Well, we know that router 4 is sending in some routes from the internet through redistribution, so that's an ASBR. And that makes sense. We see that right here. Router 4 is the originating router, and router 1 is the one generating the summary ASB. Let's do a show IP OSPF database ASBR summary and see what they look like. Okay. So 2.2.2.2, advertising router is 1.1.1.1, and it costs me 10 to reach that ASBR. But you'll notice here, in this particular case, first of all, we don't see a routing bit designation here. That's because these type 4 LSAs don't really represent routes specifically. They represent reachability to a particular ASBR. It certainly makes sense that we're going to go ahead and send in a type 4 LSA into area 0 for router 2, but notice we are not sending in a summary ASB for router 4 in area 1, because that's where router 4 exists. That's where router 4 resides. We are sending a summary ASB for router 4 in area 1, and for area 2, we are sending in a summary ASB for router 4, which makes sense. What I'm trying to figure out is why I would be sending in a summary ASB back into the same area for router 2. I'm going to table that for now. Doesn't quite make sense. We should see a similar concept. Area 3 has, well, Area 3 does not yet have an ABR or ASBR. We're going to make that later. But Area 1 has router 4 in it. Excuse me, Area 0 has router 4 in it. So it makes sense that we would send the summary ASB to Area 1 and Area 2 representing router 4, and we would not send a summary ASB into Area 0 representing router 4 because that's where router 4 is. So I'm curious why we're seeing this summary ASB in Area 2 for router 2. Not quite sure why that's happening, but we'll see if we can identify whether that happens again in Area 3 when we go ahead and convert Area 3 to a not so stubby area. One of the other things that we're going to take a look at is our type 7 LSAs and how the recursion process for type 7 LSAs is completely different. All right, we already see that we can use a type 1 LSA to recurse inside the area where the ASBR is attached, and we use the 4s to get to the 3s to get to the 1s outside of the area. All right, we also see that we're looking for that routing bit to be set to on. We are going to talk more about the forwarding address a little bit later on. If I go in here and I say show IP, show IP OSPF database, show IP OSPF database external, we can see that for the 22.22.22.22 subnet, that forwarding address is quad 0. All right, what does that forwarding address mean? What case would it not be equal to quad 0, and what does that mean? Those are questions that we're going to answer as part of the remaining part of our lesson here. Okay, so if we go in and we do a show IP OSPF database for the ASBR IP, like I said, router 1 should have a way of recursing to that router internally. Show IP OSPF database router 2.2.2.2, and we do have a way to recurse to that router internally. But if I go over to router 4, show IP OSPF database 2.2.2.2, router. Remember, routers are type 1 LSAs. We don't have a way to recurse to that ASBR using a type 1 LSA. All right. Now, one of the things that we're going to learn, we'll talk about this more in a future lesson as well, is what is the difference between an OE1 and an OE2 route. So if I look at the route here, we can see that we have two options. We can send in a route as an external type 1, or we can send in the route as an external type 2. Right? And we can see presently that that route is coming in as an external type 2. Which, by the way, is the default. I didn't do any manipulation on the redistribution process. I just did a redistribute connected subnets, and automatically the route was sent in as an OE2. From the overall metric for the external route, the effect is that that external route is going to have an initial seed metric of 20, which is cost, OSPF metric of 20, cost, and not only is it going to have an initial seed metric of 20, it is going to, that metric will remain the same as I move through the autonomous system. You might think, well, that's not great because I really want to know what it's going to cost me to reach that destination. It actually doesn't matter because of the way we recurse the routes. If I'm trying to reach that destination from anybody inside the same area as the ASBR, I'm not even going to use the external route to reach the external networks. I'm going to reach the type 1 LSA to reach the ASBR, and then once I get to the ASBR, I'm just going to use the native route, which is connected or static or through some other dynamic process to reach that destination prefix from that particular router. If I fall outside of the area, I'm going to use a type 4 LSA, at least if it's not a special area type. I'm going to use a type 4 LSA to recurse to the ABR that's advertising the prefix. And then I'm going to use the type 3 LSA to identify the prefix, and then I'm going to use the type 1 LSA to actually reach the ASBR. Okay, all right. All right, so we'll get into more. We're going to change our topology a little bit in this particular lesson to kind of see what the impact is of having multiple ABRs to reach the same destination prefix. It's an interesting concept, because one of the ABRs might be advertising the external network, but we might actually be using a different ABR to reach that destination. And I want to show you guys how we can identify whether or not that's happening in our particular topology. All right? If there isn't an entry, we're not in the area, right? So if I do, like I said here, a show IP OSPF database router, if I can tell, if I don't have a type 1 LSA to get to that ASBR, I know that that ASBR is being resolved from a different LSA type, okay? we have to make our decision to forward to the ABR, and then how do we forward to the ASBR from that perspective. So if I do a show IP route, 22.22.22.22, we can see that the seed metric again is 20. From this particular perspective, the forwarding metric is 20. The forwarding metric is actually the metric that we use to make the decision. And that forwarding metric is what we decide, is how we decide that we're going to get to that particular destination. I hope this is making sense, guys, because this is not a very complex topology. The CCIE lab will have a much more complex topology, and in the troubleshooting section, you may have to identify the actual SP shortest path resolution, or how we resolve the tree, or the graph, if you will, based on that complex topology. All right? External routes get inserted into OSPF in the redistribution process with a seed metric and a type. But again, like I said, we do not route to networks, we route to nodes. So we just have to consider the forwarding metric to get to the ABR, and then finally the forwarding metric to get to the ASBR. All right, so let's go ahead and make our path a little bit more complex. I'm going to come into my topology here, and we are going to, let's move this down a little bit, and we're going to just kind of modify this. Let's see, raise one layer, modify this topology a little bit, and we'll add another router. I will export this topology with this new configuration, by the way, so you guys can see the whole thing after the fact. So we're going to add a router 5 here, and we're going to have to go ahead and add a switch in this segment here, so we can connect all 3 nodes. Run that from the VM. Okay. All right. And we'll just call this LAN. Actually, let's just name it the subnet. How about that? All right. So that's our LAN. Put that down here. And now I forgot which interfaces that were supposed to be. Ethernet 1010. Okay, we'll use 10 on this side as well. All right. Duplicate that, put that down here. So over here. Let's go ahead and connect everything back. All right. And we're going to go ahead and add a serial link. I want to add a serial link to router 3 so that we'll have something kind of separate and unique to be able to decide how we're going to route to our particular destination. And let's make this serial link 131. All right. Power on this router, and we'll just drop in our configs here. There's a very specific reason why I'm doing this, because I want you to identify, I want you to see, now R1 and R5 are going to be acting as ABRs to area 2. And the reason why that's important is because we may not choose to go to R1 or R5 to reach a particular, to reach that particular destination. And I want to see what the effect is of having multiple ABRs to reach an ASBR. We'll set this up as a not so stubby area in a little bit, but want to see what the effect of selecting the graph is based on having multiple paths to reach this particular destination. Okay, so let's go and put in Ethernet 10, we'll make that 172.16.14.3. Interface Ethernet 10, IP address 172.16.14.3. And it should be a 128, I believe. Yep, 128. And let's do a no shut. IP router OSPF 1 area 0. OSPF 1 area 0, sorry about that. Oh, what happened? Interface Ethernet 10. Oh, enable. What the heck? OSPF 1. Let's just do it this way. First of all, let's ping the other two interfaces. 172.16, actually was it 16.14, and .4. That should be router 4. Let me check it real quick. 14.2, okay. And router 1. .1. Okay. So let's go back to router 5. We should have reachability, and 14.1. All right, so router OSPF 1, network 172.16.0.0, 0.0.0.255 area 0. So we'll get some adjacencies there, and on our serial interface, we're going to do 131. Interface serial 20. IP address 131.1. And we're going to put this guy in area 2. What I was trying to do before, but I think I forgot to put the IP in. And finally on router 3, we're going to go ahead and enable it on serial 20 here into area 3. Interface serial 20. IP OSPF 1 area 3. So did I put that in the right area? I think I put it in the wrong area. Did I configure the wrong router? I did. Stupid, stupid. Oh yeah, we're doing router 5. I apologize, but I did put it in the wrong area. It should be in area, it is in area 2. Sorry guys, I'm a little rusty. It took too much time off. Let me go back to router 3. Config T. IP OSPF 1 area 2. All right, so we're going to get our convergence here, which means now that that external route should be advertised from multiple ABRs into router 4. So what I want to do is I'm going to do a show IP OSPF database, ASBR, show IP OSPF database, ASBR summary. And we can see here that router 1, sorry, I apologize. We need to go ahead and put some routes in here. All right, so we've got our loopback. Let's do this. Let's create interface loopback 100 in this topology. Duplicate that. And we'll make it 33.33.33.33/32. And we're going to send that in as redis EIGRP. All right, so we're going to put that into EIGRP, and then we're going to send it into OSPF from the EIGRP process. What we would probably most likely want to do, I mean, if we had some extended networks beyond this router and we had other networks that were not attached just via loopback, I'd have to do mutual redistribution so that I would have DEX routes in my EIGRP domain and I would have my OE whatever routes in my OSPF domain. But I don't want to add another router on top of this. So let's go into router 3. Interface loopback 100, IP address 33, 33, 33, 33, 255, 255, 255, no shut. And router EIGRP 100, network 33.0.0.0, router OSPF 1. And let's redistribute this route. For now, let's go ahead and leave it as an E2. We're going to redistribute EIGRP 100 subnets, and that's it. Okay, so we're going to send in the EIGRP routes. It's going to come in as an OE2 route, and now router 3 is also an ASBR. If I do a show IP Ceph, 33, 33, 33, 33, we do have a reachability to 14.1. So it looks like we're going to router 1 to reach that particular destination. But if I do a show IP route to 33, 33, 33, 33, what you see here is a metric of 20. Now this is really interesting because router 3 is the one that's advertising the route. But we're not going to router 3 to get to that destination. If I do a trace route to 33, 33, 33, 33, we can see that we're going from router 1 over to router 3. This is what I was talking about when we were talking about the database and the recursion that we use in OSPF as opposed to what we see in the routing table. Now it makes sense, right? It makes sense if you look at the topology that I would not use router 5 to get to that destination. In fact, let me go into router 5 real quick and just set the router ID to router 5. Let's do router OSPF 1, router ID 5.5.5.5, do clear IP OSPF process. Yes. Show IP protocols, just so we can recognize it easily in our database. Okay. So our router ID is now 5.5.5.5. So if I go back to router 4, like I said before, we're tracing a route to 33, 33, 33, 33, and we're actually using router 1 as the destination. Now, router 3 is the ASBR that's advertising that external prefix. Router 3 is the ASBR that's sending the route into the topology. So it's very interesting that we're seeing the ASBR IP address as the kind of the next hop for this particular destination, but we're obviously not using that router as the direct next hop. We have to either choose to go through, if you look at our topology, to choose to go through router 1 or choose to go through router 5. Now, if I do a show IP OSPF database, we will see in this particular case that I get a summary ASB link from router 2 and router 3. If I look at my topology here, router 2 and router 3 are my ASBRs. So that makes sense. But look at who the advertising router is. In both cases, it's router 1. So even though router 5 is a router, in fact, let me go to router 1, check my topology again. Go. Good job. Sorry about that, guys. So I'm going to check my topology again. What I'm going to do is I'm going to shut down Ethernet 1.2 on router 1, just so you can see that we do have reachability from router 5. All right, go to router 4, do the show IP OSPF database command again, and eventually as we converge, what I should see is an ASB link state advertisement from router 5. Let me make sure I didn't mess something up here. I was kind of going pretty quickly here. Let's do a show IP OSPF interface on router 5. Serial 20. I do have a problem. So interface Ethernet 10. No shut. Do show run. Interface Ethernet 10. And let's go into, let's do IP OSPF 1 area 0. I thought I had included that interface in the routing process. All right, now I should be a summary, yeah, okay. There's my summary ASB from router 5. Regarding router 3, again, this is the ASBR, this is the ABR that's advertising the type 4 LSA. What I should see is I should see something from both routers. So if I come into router 3, router 1, and I do a no shut, let's go back to router 4. And what I should see eventually as I converge, any day now, got my adjacency, show IP OSPF neighbor. Router 5 is a neighbor. What I should see, there we go, just didn't give it enough time. So just to back up a little bit, because I'm kind of jumping around a little bit here, but this is exactly what I should see. I should see 2 type 4 LSAs coming in representing the ASBR, because both of those ABRs know how to reach that ASBR. But it doesn't mean that I'm using both of those routers to reach that destination. If I do my trace route again to, was it 33, 33, 33, 33, you can see that I'm going through router 1 to reach that destination. So even though both ASBRs are advertising reachability to, both ABRs are advertising reachability to that ASBR, we're only using one of those ASBRs to reach the destination. If I do a show IP route, 33, 33, 33, 33, we can see that the last update was received from 14.1, which is router 1, with a metric type of 20. Now, if I come back into router 1, let me go back to my topology, and I shut down Ethernet 1.2, the only way that I should be able to reach that destination is through router 5. But before I do that, let's investigate something else. Show IP OSPF database. So what you'll notice here is that even though I have 2 entries to reach the ASBR, 2 type 4 LSAs, I only have 1 entry for the type 5 route. Does that make sense? I have 2 ways to reach the ASBR, but I only have 1 entry to reach that destination. And if I do a show IP OSPF database external, we will see that to get to 33, 33, 33, 33, the advertising router is 3.3.3.3. Forwarding address is quad 0. If I type in show IP OSPF database router, 3.3.3.3, I have no type 1 LSA to reach 3.3.3.3. So then the question would be is, how do I know which router I'm using to get to that external network? And that's where the type 4 LSAs come in. Show IP OSPF database. And we have 2 ways to reach 3.3.3.3. So what this router is going to say now is, how do I get to that particular destination? How do I get to 3.3.3.3? If I do a show IP OSPF database, ASB, show IP OSPF database, ASB summary, if I choose to get to 3.3.3.3 using router 1, it's going to cost me 10. If I choose to get to 3.3.3.3 using router 5, it's going to cost me 64. So the type 4 LSA is describing the best ABR to go to reach the ASBR. All right. I think we finally got there. I think you guys understand what I'm trying to point out here. I mean, naturally it makes sense. You look at the topology, and obviously this top path is going to be more preferred than the bottom path because of the overall metric, the overall path metric. If I were to shut down Ethernet 1.2 on router number 1, interface Ethernet 1.2, config T, interface Ethernet 1.2, shut that down, and I go back to router 4, show IP route 33, 33, 33, 33. The metric for that path is still, well, we're not quite converged yet. There we go. The metric for that path is still 20. It's good that we did that twice. This was the before picture. This is the after picture. So when OSPF is making a routing decision, it's not basing it on this metric, it's basing it on this metric. Kind of a long way to get to that discovery. I didn't really describe it very well, but I think you guys understand. Okay. Now, how does all of this change if we decide to make this a special area type? All right. There are 4 special area types. We talked about the 4 special area types when we were discussing, special area types. We have a stubby area, which only allows type 3s in, allows everything out, and it injects a default route. The ABR injects a default route. 1s and 2s, of course, will exist within the area, but only type 3s are allowed to come into the area, and you're not allowed to have an ASBR attached to a stub area. Then you had totally stubby area, which allowed nothing in except for essentially a type 3 default route, a route being injected by the ABR. That's going to come in as a summary route, OIA route, and everything is allowed out, but nothing is allowed in, just that default route. Then we have totally NSSA. I skipped NSSA for a reason. We have totally NSSA where nothing is allowed to come in, but we're allowed to attach an ASBR to that particular area, and a default route is still going to be injected by the ABR. The difference is we don't see type 5s within the area. We only see type 7s that get translated to type 5s at the ABR. But then we have this other area type called an NSSA, and the reason why we focus so much attention on it is because of the way it handles the default route. And frankly, if you're going to do a stubby area, you might as well do an NSSA, because then at some point you can always add redistribution to that area later on if you want to. Okay. We're going to be leaking our external routes into the backbone and throughout the area. Now they're coming in as OE2s. They're being sent in as type 5s because we don't have any special area types. And they're going to stay type 5s throughout the OSPF autonomous system. NSSA is the only one that does not inject a default route into the area from the area border router. There are some specific cases where this is useful, but there are a lot of cases where this is very problematic, where you don't have a default route because you're going to lose reachability information to the rest of the prefixes. It all has to do with the concept that I mentioned in one of my previous lessons called hot potato versus cold potato routing. I don't think you'll see this term on either the written or the lab because it's not really a term that's defined by Cisco, but hot potato routing means that we're just going to basically try to route to those external networks the closest way possible, whether it's in the area, outside of the area, regardless. Cold potato routing is where we're just trying to find the best route through the core, routing to our nodes, and then we'll make a decision on routing to the external networks once we've reached the external, or the ASBR. I don't think we're going to get into some configuration scenarios where we look at hot potato versus cold potato routing, but I don't really think it's that important anyway for you guys to understand for the class. All right. So we've got our EIGRP route being redistributed on router 3, which now makes router 3 an ASBR. Those type 5s are being generated. They're being sent everywhere. If I go on to router 4, which is at the edge of my area 0, and I do a show IP OSPF database external, I can see that the 33 prefix is coming in. The advertising router is router 3, which is the ASBR, and the forwarding address is set to quad 0. We can also see that the routing bit is set, so that means that we have full convergence. We have reachability to this particular destination. We're not seeing it from anywhere else right now. The type 5 LSA, like I said, does not really describe how we reach the ASBR. I would have to take a look at my type 3s and my type 1s. Well, type 3s first and then my type 1s to get to the ASBR. So what we're going to do now, this is kind of the last step. We still have a little bit left to talk about, but what we're going to do now is we're going to convert area 2 to a special area type. One of the things that you need to do is once you've set one of the routers in the topology as a special router, whether it be a stub or not so stubby router, all of the routers have to be configured the same. So you will lose adjacencies if you're converting an area from one type to another. Very important concept. You will lose adjacencies, so you don't want to do this during production hours. All right. Okay. So let's go ahead and convert area 2 to a not so stubby area. We're going to have to do that on router 1, router 5, and router 3. Pretty simple concept. I'm going to have the benefit router 1, router 3, and router 5 of doing this all at once. And let's do a config T, router OSPF 1, and area 2 NSSA. All right, and we'll just send in a write too. Okay, so router 1 is being converted, area 2 is being converted to an NSSA. Did I do the wrong router again? Jeez. I did router 3. Yeah, the router 3 is correct. I didn't do the wrong router. All right, and router 5. Okay. You see my adjacencies did reset once I did that. Something to keep in mind, which I think you guys were probably already aware of. But this is going to change completely how OSPF resolves the graph. All right. Let's start by taking a look at what changed on the area border router. 5 is an area border router. I'm going to do a show IP route. And one of the first things that you're going to notice is that we now have an N route as opposed to an E route. N stands for not so stubby. All right, so which also corresponds to a type 7 LSA. So we're getting a type 7 LSA. It's still coming in as N2. It still has a default seed metric of 20. Just like in E2, the N just simply means that this is now a different type of route. So let's do a show IP OSPF database and see what that looks like in our database. And sure enough, instead of seeing a type 5 LSA for 33, we're seeing a type 7 LSA. If I was to drill down into that, show IP OSPF database, and in this case, I'm going to do a NSSA external. We can see that the routing bit is set. That's good. That's one thing we always want to check. Type 7.5 translation is allowed on this particular prefix. I don't know if we'll get into the concept where translation would not be allowed. There are special cases where you may not want type 7s to leave the area, the special area type. So you would say translation would not be allowed, which means the ABR is not going to be able to convert that to a type 5 and send it in. But in this case, translation is allowed. Also notice the forwarding address. The forwarding address is the physical IP address of the ASBR that's originating this route. It's no longer quad 0. All right. So basically what router 7 is saying is, hey, when you do your recursion, you need to recurse to 192.168.3.1. All right. Now, if I was on router 5 and I do a show IP OSPF database, and we can try to do the 192.168.3.1. Let's do router. I don't see that in specifically, but if I try to recurse to the ASBR, which is 3.3.3.3, I can see that I still do have a type 1 LSA to reach that particular ASBR. Same concept if I go to router 4, show IP OSPF database. The summary ASB link is coming in for router 2, but we're not seeing a summary ASB for the external network anymore, which is a really interesting concept, right? You would expect to see a summary ASB, a type 4 LSA, that's being generated for that external route. We don't see that, okay, because of the transitive properties or the translation that's occurring from type 7 to type 5. Really, really interesting concept. I would normally expect to see a summary ASB for type 4 LSA, but we don't use the type 4 LSAs anymore to reach that destination. If I do a show IP OSPF database, let's do summary 3333, 3333. Of course, we're not getting any type 3s. If I do a router LSA, we don't get any type 1s, but if I do an external LSA, try that again. All right, we can identify that we're reaching that destination. The advertising router is 5555, which is the area border router. Remember, our Ethernet interface is shut down. We're going to turn that on as one of our last steps here and see how that affects our routing. Okay. And you'll notice that the forwarding address, again, is still not identified as quad 0. All right. So we aren't using type 4s to reach this destination anymore because router 4 doesn't have any type 4s for that particular ASBR. That means that we have to use our type 1s and our type 5s to reach the destination. If I did a show IP Ceph for 33333333, we do have reachability. Let me go ahead and turn on Ethernet 1.0 on router 1. And let's see what the effect of that change is going to be on that router. Okay. Now we have multiple ABRs. As I mentioned, and this will kind of be the last thing that we discuss before we decide to wrap everything up. But as I mentioned, we are not going to use both ABRs to reach that destination. Even if they were equal cost paths, we would not use both ABRs to reach that particular destination. There's an election process that takes place, and we choose which ABR is going to do the translation for the type 5 LSA or the type 7 into type 5. So if I look at now show IP OSPF database external on router 4, let's just look at the database to start with. We can see that type 5 LSAs are still being advertised by router 5. So that's the advertising router. Now, if I look at my topology, that's not how I should go to reach that destination. 333333 should not go through router 5 to reach that destination. If I do a show IP Ceph for 33333333, you can see that I'm actually going to 14.3. 14.3, actually, let me look at, yeah, let's do a trace route, actually, because that's just the next hop. Let's do a trace route. 33, 33, 33, 33. And you'll see that, that's strange. I am using router 5 to reach that destination. That should not be happening. Let me make sure. Show IP interface brief. Ah, I turned on the wrong interface. But I guess this is kind of the point. If you understand how OSPF is supposed to make its decisions, then you would be able to understand fairly quickly that it's not converging the way that it should be converging. Let's go back to router 4. Show IP OSPF database. All right. So we're seeing in this particular case that type 5 LSA is still being advertised by router 5. Let's go ahead and refresh. Refresh, refresh, refresh. But if I do a show IP route, let's do that. Show IP route 33, 33, 33, 33. The forwarding metric is 21. Okay? Which is a lot different because it looks like that forwarding metric is much, much lower than what I would expect to see to reach that particular destination. If I do my trace route, I mean, it's exactly what it should be, but it doesn't include that serial link. So even though router 5 is the one that's advertising the external prefix, we're not using router 5 to reach the destination. That's really the point that I'm trying to make. Before we were looking at the type 4 LSAs to identify the best way to reach the ASBR. Now we're looking at the type 5s, and then we're looking at the type 1s to reach the ABR. And that's really the most important concept of this. There's this disconnect with type 7s to type 5s. It's not quite as clean as it was with just the type 5s. I'm giving the route by router 5, but router 5 is not part of the data plane processing for the packets for that destination. The advertising router is not the ASBR. The advertising router is the ABR. We see a forwarding address of the ASBR. Let me see. Let's do... I want to see if I can show you one more thing here. Show IP OSPF database. Gosh. Show IP OSPF database. External. So for 33, 33, 33, the advertising router is the ASB or the ABR, but the forwarding address is the ASBR's IP address. In the previous example, the forwarding address was quad 0, which indicates basically me. I'm the forwarding address. So we're saying, okay, we need to get to 5.5.5.5 to be able to reach this external network. Here we're specifically identifying an IP address on the ASBR, so we're going to use a completely different recursive process to resolve the graph to reach that particular destination. Okay? In other words, 5 routes are no longer recursing to 4s, but now they're recursing to 3s. Right? If I do a show IP OSPF database, 192.168.3.0 summary, we're recursing to a type 3 to reach the type 5, or the type, well, essentially, in essence, the type 5. All right? So we got our recursion process is we're going from a type 7. It's getting translated to a type 5 at the ABR. Instead of using the type 4s to reach the ABR, to choose the ABR and then get to the ASBR using that type 4, we're going to recurse to the ABR using the type 3s for this prefix because of the defined forwarding address in the type 5. Before, it was just 5.5.5.5 with quad 0, so that basically told the router, hey, if you want to get to that external network, you need to recurse to 5.5.5.5, which you use the type 4 to do that. And then once you recurse to 5.5.5.5, you're going to recurse to the external network using the type 1. It's really, really interesting, right? I think it is. If you have a good understanding of how these routers interact with each other. All right? Essentially, we're just trying to choose overall who's the closest router to the external network. Basically, the shortest path to the NSSA. So we're going to use an intra-area SPT calculation as opposed to an inter-area SPT calculation. So for example, if I come into router 4 and I do a show IP OSPF database, show IP OSPF border routers, I can see where my ABRs are, what the cost is to get to those ABRs, and then I can identify, which one's the best one to go to reach a particular destination. All right. We see 14.1, we see 14.3, and that's how we're going to route to get to that type 7 LSA. All right. Notice we see a reference to not only ABR, but ASBR. And that's very important. Okay. Obviously, router 2, if you look at this topology, router 2 is not a border router, but it is an ASBR. So it's not officially an area border router, but we're looking at border routers all together. So in essence, what's happening here is that the ABR says, look, I can tell you about the route, but I'm not the best choice to reach that particular destination. Now let's say that we try to break this, right? Because what I want you to what I want to show you is what happens if for some reason, and obviously this would not be something that you would see on the exam, but what happens if for some reason the external network is not available? So let me think about how we can break this. We know that we're going in our topology, we're going through router 1 to reach that destination prefix. So I'm going to come into router 1, and I'm going to create a IP route to 33.33.33.33, and I'm going to send that to null 0. Okay. Now if I come to router 4, show IP OSPF database, does it change anything from router 4's perspective? The advertising router is still router 5 for the 33.33.33 subnet. By the way, that's based on router ID. Router 5 has a higher router ID than router 1. So that's how we choose who's going to advertise the external link. If I do a show IP route, I can still see the 33 subnet in my routing table, but look where the packet is going. It's going to 14.1. So is OSPF smart enough to recognize that the recursion process is going to fail? Let's do a show IP OSPF database, external 33.33.33.33, and router 5 is the destination. I'm going to try to recurse to the 3.0 subnet using my summary LSA, show IP OSPF database, summary 192.168.3.0. So I do have a way of reaching 3.0, but notice the metric is 65. So, all right, sorry, excuse me. Router 5 is advertising that prefix, so is router 3. That might actually not break our routing. So let's do this, ping 33.33.33. Yeah, so we are getting an unreachable. So the question is the routing bit set for a particular destination? We can see that the routing bit here is set, but the routing bit here is not set. So we are getting type 3 LSAs to represent the 3.0 subnet, but this is the path that we're choosing to get to that destination. So if I go to router 1, now I have to recurse to the 192.168.3.0 subnet with my type 1 LSA. Show IP OSPF database router 192.168.3.0. Actually, let me show IP OSPF database. And let's do show IP OSPF database router. And what I should see is the 3 subnet. Actually, let's try this again. I'm looking for the, let's do this. Let's do a begin area 2. So router 1, that's fine. Router 1 is in area 2. Router 3 is in area 2. So this is kind of interesting. What's happening in this particular case is we are able to, and this actually, well, it says a stub network. We don't have reachability because obviously we're going through router 1 to reach the destination. What I was trying to see is if I could show you whether or not the routing bit would be set or not based on the failure that based on that null zero route that we created. But I don't think we're going to get to see that because this is being treated as a multi-access network. And I don't believe that we're going to see show IP Ceph 33, 33, 33, 33. Yeah, so it's just attaching the route to the null zero interface. I'm trying to think of how I could show you that the you know what I need to do? I created the null zero route to the external network. What I need to do is I need to create a null zero route to the forwarding address. That will break it. So let's go ahead and take that route out. Do show IP route static. All right, so let's do no IP route 33, 33, 33, 33, 255, 255, 255, 255, null zero. No IP route. And let me think about how I want to create this. If I want to break this, I need to create a null zero route for the forwarding address. I should be able to do that on router 4 because if I do a show IP route 3330, let me do a show IP OSPF database, sorry. 33, 33, external. 33, 33, 33, 33. I can see that the next hop is 3.1. So let's try that. Let's do an IP route to 192.168.3.1. 255, 255, 255, null zero. And now let's do a show IP OSPF database external. Ah, dang it, the routing bit is still set. And I can still reach it. Show IP route. Did it take my route? It took my route. Let me try it on router 1. I know that this will break it eventually at some point. Not sure. I thought if I did the static route to null zero on the either router 4 or router 1, that the routing bit would Let's try it one more place. There's only one other place you could put it. And that would be on the source. Well, that wouldn't make a difference because that's going to be a static route, which is going to have a higher administrative distance than the connected route. Oh well, I guess we'll table that for now. I'll try and maybe show you guys how to break some things a little bit later on in some of the more advanced topics, but should have been able to break it so that that routing bit was not set, but I was not able to. That's okay. So hopefully you guys got a lot from this lesson. We didn't spend a whole lot of time talking about NSSA specifically because there's really not much to say about the actual configuration of NSSA. It's just an external network, right? It's just to make the area NSSA and redistribute some routes from an ASBR. But what's more important is to understand who advertises the external route versus who's routing the external route. How do we make decisions on recursing the SBT tree, and how do we build the graph to reach the nodes in the networks? All right, so we'll go ahead and wrap up this lesson, and we'll see you guys in the next one.